Right, we are live. But your port is not loading, brother. Okay. Hmm. So let's. Okay, we were on 4.3. We ran the sanity check. And then data set, train, and evaluation. Huh. I was the ground truth before training on it. And then it reproduced some. Torch.float, torch.float, 32 0.1 range, 2 dot tensor, 0 to 255 को divide कर दिया, boxes 1 to 4, 1 box 4 chords. XY format, X1 Y1 X2 Y2, 1 X1 0 collate. Okay. Def collate return tuple zip batch. Q set tuple examples. Okay, def collate normal data loader batch को एक रेक्टेंगुलर टेंसर में स्टैक करता है डिटेक्शन में नॉर्मल डेटा लोडर को एक रेक्टेंगल टेंसर में स्टैक करता है डिटेक्शन में ये इम्पॉसिबल है इमेज 1 में 3 बॉक्सेस हो सकते हैं इमेज 2 में 0 इन्हें टेंसर में स्टैक नहीं कर सकते इसलिए बैच एक्ट के रूप में रहता है और फास्टर आरसीएन एग्जैक्टली यही एक्सपेक्ट करता है ये लाइन हटा दो तो स्टेप 6 पहले ही बैच पर फेल हो जाएगा ओके ऑगमेंटेशन सिर्फ ट्रेन पर कलर जिटर ब्राइटनेस कॉन्ट्रास्ट सैचुरेशन ह्यू सिर्फ ट्रेन पर लगता है सिंथेटिक डेटा पर ये खास तौर पर इम्पोर्टेंट है रेंडर इमेजेस में सेंसर नॉइज ब्लाइंड्स आर्टिफैक्ट लाइटिंग वेरिएशंस कुछ नहीं होता असली कैमरा ये फ्री में देता है जिटर को कमी पूरी करता है सो वाल डीएस कोई ऑगमेंटेशन नहीं ट्रेन डेटा सेट कलर जिटर, ब्राइटनेस, कॉन्ट्रास्ट, सैचुरेशन, ह्यू सब ट्रेन पर लगता है। सिंथेटिक डेटा पर ये खास तौर पर इम्पोर्टेंट है। रेंडर्ड इमेजेस में सेंसर नॉइज, लेंस आर्टिफैक्ट, लाइटिंग वेरिएशन। अकोमोडेशन इसलिए नहीं क्योंकि इवैल्यूएशन डोमेस्टिक होनी चाहिए, वरना रन और अलग एमएपी आएगा और तुम कंपेयर ही नहीं कर पाओगे। ओके, basically we are trying to measure the MAP at the end.
Mean average something.
I don't think it's mean average. I think it's precision, but MA is something else. It's not mean average. P is for precision, I think, but mean average precision. Okay. Mean average precision. Okay, so let's So kitty detection dataset is a wrapper that knows how to turn on kitty image label file into image tensor target dict pair matching the format the detection model expects. In it stores the image class list, and if you don't hand it a specific file list, scans the images folder for every .png stem file name minus extension. Load boxes. What the fuck is this? Kitty detection dataset is a wrapper that knows how to turn one kitty image plus label file into image tensor target depth pair matching the format the detection model expects. Okay. In it stores the image slash class list. Image slash class list. And if you don't hand it specific file list, scans the images folder for every .png stem file name minus extension. Load boxes reads a kitty.txt. Oh, by the way, we need to order this for our next assignment.
Studio $46 China, $260. How much?
Hmm?
We are looking for sponsors. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 2 that can sponsor our tech.
Yeah, bro, I think we will have to spend a little bit for like maybe a couple of $100. Because the one that I saw on Amazon, and I'm just flagging this to you because this is going to be our next project.
Hmm. Web interface.
I think I saw, or something like this. Open source compatible with NVIDIA Jetson. Oh yeah, developed with Isaacson Groot in one.
Hmm.
I think I will have to assemble it if I order it.
Hmm.
But this would be a fun stream, bro.
Hmm.
Like doing this on stream. What do you say?
Yeah, definitely, bro. It would be fun. Oh, Hugging Face is getting bought by some private firm. I don't know for $13 billion.
13 billion.
Yes, brother. 13.
Oh my god, bro. And they didn't have any investors, right?
Yeah, I don't know. Like, I think they were pretty much open source and bootstrapped.
Bruh.
13 billion
Life changing money.
American dollars.
What do you, so can you take a look at a cheaper one or, for a deal or something?
Yes, brother, we can. I think we can find it on Alibaba for sure. Sure.
But Alibaba will take like a month, bro. And it's almost gonna be the same price.
I
Because
don't think, bro, it's gonna be the same price. The tariffs are moved already. And definitely, like, dude, they will have a cheaper version. If not, then you
I
have,
think I did see a cheaper, like,
because the thing is, the manufacturer is gonna be almost the same. I would say that.
this is AliExpress, bro, $46, but this is something else. You see $39, right?
Mm-hmm.
But this is only the fucking motor DIY. I don't know what that is.
Mm-hmm.
Without 3D parts. I don't know what that means.
Mm-hmm.
Yeah, this like the complete kit is 285, 282. Because you know what I want to test?
Mm.
I want to basically build out our prototype for Instructs and then test it on this.
Wow. $22 over this. Yeah. Wait, dude, it has compatible with them deploy. Interesting stuff. Interesting.
Hmm. So I'm just flagging it to you. So look for it.
Yes, brother, I will.
Okay. Moving on. In it stores image class list, and if you don't hand it specific file list scans images folder for every .png stem file name minus extension. Load boxes reads kitty.txt label file line by line. Keeps only lines whose class is one you care about and skips any box with zero negative width, zero/negative width or height. Get item is called per sample. It loads the image, loads its boxes, optionally applies color jitter, converts everything to sensor tensors. Okay. Get item is called per sample to loads the image, loads its boxes, optionally applies a color jitter, converts everything to tensor. It optionally flips the image horizontally, a data augmentation, and critically flips the box coordinates to match. Each sample returns decked with boxes, labels, image, ID, area, and is crowd. The exact schema torch vision detection models expect. Each sample, okay. Color jitter converts everything to tensor that optionally flips the image horizontally a data augmentation. Each sample returns decked box labels, ID, area, and is crowd. The exact schema torch vision need detection. Okay, collate F fun tells data loader how to bundle several samples into a batch needed because each image can have different numbers of boxes. Okay. Hmm. Okay, the most important part to actually understand the horizontal flip block because it's one place a small bug silently corrupts your labels. If self dot h flip prob and random dot random self dot h flip dot underscore prob image t is equal to image t dot flip minus one. If len box is t, w is equal to img t dot shape. Hmm. Box is t equal to okay to plus torch tensor plus torch tensor. Here's why. If you flip the image left to right but forget also to flip the boxes, your model trains on images where the object is on the right but the label says it's on the left. This is a classic easy to make bug that doesn't crash anything. Training runs fine, loss goes down, and the only you only discover it much fast later than when the model's predictions are mysteriously bad and mirrored. Okay, what the math is actually doing? A box x1 y1 x2 y2 left edge top. Okay, after a horizontal flip, what was right edge x2 becomes the new left edge. What was left edge X1 becomes the new right edge. So boxes T2103 reorders the column X2 Y1 X1 Y2, swapping X1 and X2 while leaving Y1 and Y2 untouched. Then it mirrors X coordinates around the image. New X is equal to YW minus 1 minus old X, which is exactly minus 1, 1 minus 1. Okay, okay. Compute negate X and W minus 1. Leave Y alone by multiplying by 1 and adding 0. Why this matters more than the rest of the file. Everything else in this code, loading images, batching the train val, split is standard boilerplate. You'd write the same way for almost any dataset. This flip and remap logic is one spot that specific detection and easy to get wrong for classification. Flipping an image and not touching the label is fine since the label is just for cat, just cat for detection. The label is spatial, and so any geometric transform on the image, flip, crop, resize, rotate must carry the exact same transform through to the box coordinates, or your ground truth becomes wrong in a way that's invisible until you dig into predictions. One consequence worth flagging in the code as written by LDS is created without flip prob, so validation images are never flipped. Good, since you generally want validation eval data left unaugmented, so your metrics reflect real performance, not augmented performance. Okay. Ground truth with augmentation. Okay, create step.
Specify training parameters. Batch size, see the nodes below. The default is stream polymer machine. Number of epochs.
Mhm.
Main wall, clock, lever, learning rate, scale, roughly, linearly with batch size.
SDG with momentum and cosine schedule is the standard recipe for faster RCNN. A short warm-up avoids the low spike and then untrained detection head otherwise causes in the first few hundred iterations. Batch size on the with this machine measured on GB10 1280720 is exactly model AMP on. What is AMP?
Average mean precision. I don't know, bro. Google it up. I don't know what's AMP.
I think it will explain in the thing that I'm creating over here.
Okay.
Yeah, I at least wanna start the training today
Mm-hmm.
for this.
Train the model.
So batch size on the this machine measured on GBDM blah 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 peak GPU memory throughput throughput plateau 16 and even 32 uses barely tenth of 130 GB unified memory, so the usual result until you OOM advice is wrong instinct here. You will never OOM before you stop gaining speed. The default is 16 learning rate is scaled to match. The standard false RCNN label is LR is equal to 0.02 at batch 16. If you change batch size scale the LR linearly batch size batch 8 1 e to the power minus 2 batch 132 4 e to the power minus 2. Okay, STG with momentum and cosine schedule is a standard recipe for a short warm avoids a low spike that an untrained detection had otherwise caused. The first few hundred iterations batch size on this machine measured on GB10 1280720 with exact model AMP batch. Okay. So it plateaus on 16. What exactly plateaus on 16? I'm unsure. Parameters P for P in model dot parameters if P requires grad. Optimizer equals to torch dot optim SDG parameters. What does this do? Torch dot optim dot SDG synthetic data generation.
Yes. No, it's not synthetic data generation. Uh,
SGD, sorry, my bad. Optim dot SGD.
it's a optimizer. I don't know how I can explain. Like you can just Google it up, dude. But it's a optimizer that basically changes your value. Uh, I cannot explain, bro. I cannot explain it in a proper way. That's why I will just say that. Time for Gemini. Oh yeah.
Is a PyTorch implementation of stochastic gradient descent, the optimizer that actually updates your model's weights during training. This is very important. Using the gradients that lost or backward computes. Oh shit.
Yes. This is
And
enough.
it is going to work with parameters, learning rate and momentum. Point 0.9 weight decay is equal to weight decay. And what have we set as weight decay over here? Float ENV weight decay 5e minus 4. So 5 into 10 to the power minus 4, which is going to be 0.0005. Weight decay, learning rate. Okay, okay. Oh, it's starting to make sense. Iterations per epoch is equal to max. What the fuck is it doing? Okay, it's complete. हम्म। अब तक हमने डेटा और मॉडल बनाया, समझ आ रही है?
Yes, brother, बिल्कुल.
We have created the data and the model. ये step decide करता है कि model कैसे सीखेगा. So this step decides how will the model learn. कितने बड़े कदम किस रफ्तार से और कब धीरे होगा. पूरा स्टेप सिर्फ 4 ऑब्जेक्ट्स बनाता है बस. इस स्टेप में क्या सीखोगे? ऑप्टिमाइजर, स्केड्यूलर और स्केलर तीनों का काम अलग अलग है, साफ साफ. आई सी. सो ऑप्टिमाइजर, scheduler and scalar. Okay. Oh. Ah. Torch dot amp dot grade scaling grad scalar. Two more training loop utilities. One control the learning rate over time. The other makes precision training numerically safe. Torch.optim.lr scheduler, lambda LR, learning rate rescheduler, running rate scheduler changes LR over the course of the training according to the function you supply instead of keeping it fixed. Lambda LR is the most flexible generic scheduler. You give it to a function and that takes the current epoch or step number and returns a multiplier on the base LR. Optimizer is equal to torch.optim .stg. Okay. The actual LR used at any point base LR lambda current epoch. So if base LR is equal to 0.005 and the LR lambda returns 0.1 at epoch 5, the effective LR is going to be 0.0005. Why this matters for detection training specifically, it is very common to warm up the LR for the first few hundred. Start small, ramp up because early stage training in the model weights are far from good and full size LR can cause the loss to explode or diverge. Especially for detection models where the loss is sum of several different loss terms, then later you typically decay the LR, step it down so the model can settle into a more precise minimum rather than oscillating around lambda LR. Around it. Lambda LR is a tool you would write that exact warm up then decay schedule by hand. Okay, lambda LR. So this is a scheduler for the learning rate.
Hmm.
LR at oh, got you. I'm getting it, bro. Then later you just typically decay the LR step it on the model can. Okay. Okay, torch.amrod, grad scalar, part of PyTorch automatic mixed precision. Automatic mixed precision. system used alongside AutoCast to train float 16 half precision instead of float 32, which is faster and uses less GPU memory, especially on modern NVIDIA GPUs. Float 16 half precision. So for some reason, float 16 is better than float 32 because it is more efficient.
But it's not that precise. That's the draw.
No, it is the same.
It says half precision, bro. Right over there.
Float 16 has much smaller numeric range than float 32 during backpropagation. Gradients are often very small numbers, small enough that in float 16 they can underflow to exactly zero, at which the point gradient is just lost, and that way it makes stop learning from that step. The fixed loss scaling before calling dot backward grad scalar multiply scales up the loss by large factor. Example 666555536, which proportionally scales up the every gradient to pushing those tiny values back into float 16's representable range so they don't vanish. Then right before the optimizer actually applies the update, it divides the gradient back down by the factor so the actual weight update is correct. I see. Okay. Hmm. So it's saying over here LR at फंक्शन की 7 लाइंस जो पूरे ट्रेनिंग का एल आर कर्व बनाती है. ओके, सो दिस इज द एल आर एट फंक्शन. Linear warm up then cosine decay as a multiplier on base learning rate. If it is smaller than warm up iterations, return it plus 1 divided by max 1 comma warm up iterations progress is equal to it minus warm up iterations max 1 comma total jitters thermometers. Okay. वार्म अप क्यों चाहिए और बिना उसके क्या टूटा है? गोप्स डीके का शेप और उसका लॉजिक रैट स्केलर क्या प्रॉब्लम सॉल्व करता है स्टेप 2 वाली एफपी सेक्शन में? उससे एलआर का कर्व बनाओ. एएमपी कौन है? एक सेफ्टी स्केलर बना लो. ट्रेनिंग अभी शुरू नहीं होती है, सिर्फ तैयारी है. कोड कोड लाइन बाय लाइन पूरा सेल. यही है पैराम्स पी फॉर पी इन मॉडल पैरामीटर्स. एफ पी रिक्वायर्स दैट मॉडल में 28.3 मिलियन पैरामीटर्स है लेकिन 28.1 ट्रेनेबल पैरामीटर्स हैं. स्टेप है. ओके, कौन वन एंड लेयर वन फ्रोजन है. ये लाइन फ्रोजन वाले छाट कर हटा देता है. एस जी डी हर पैरामीटर के लिए एक मोमेंटम बफर रखता है, यानी एक एक्स्ट्रा कॉपी. अगर तुम फ्रोजन पैरामीटर्स भी दे देते तो उनके लिए भी मेमोरी अलॉट होती. बिल्कुल बेकार, क्योंकि उनका ग्रेडियंट कभी आएगा ही नहीं. रूल याद रखो, ऑप्टिमाइजर्स को वही दो जो एक्चुअली बदलने वाला है. ओके. एसजीडी हर पैरामीटर के लिए एक मोमेंटम बफर रखता है, यानी एक एक्स्ट्रा कॉपी। अगर तुम फ्रोजन पैरामीटर्स भी दे देते तो उनके लिए भी मेमोरी अलॉट होती है बिल्कुल बेकार, क्योंकि उनका ग्रेडियंट तो कभी आएगा ही नहीं काम, कभी आएगा ही नहीं। वही तो जो एक्चुअली बदलने वाला है। लाइन टू ऑप्टिमाइजर लेमन भाषा। सोचो तुम घने कोहरे फॉग में एक पहाड़ी पर खड़े हो और नीचे से उतरना है। कोई बात नहीं दिख रही, सिर्फ अपने पैरों से नीचे नहीं, ढलान स्लोप पता चलता है। ऑप्टिमाइजर वही बंदा है जो ध्यान ढलान देखकर आगे कदम लेता है।
Oh, descent, or ascent.
हम्म।
How steep is the curve, and how deep is the curve?
ओके। ओके। LR is 0.02, मोमेंटम 0.9, VD के 5 - 4। कदम कितने बड़ा है? बड़ा इज इक्वल टू तेज लेकिन मिनिमम को क्रॉस कर सकते हो, छोटा सेफ लेकिन धीमा। ओके। पिछली डायरेक्शन का 90% याद रखो, जैसे गेंद लुढ़कती है। ओ भाई,
What happened, bro?
गेंद लुढ़कती है।
Yes, brother. It's gonna tumble. It's gonna tumble.
आई गेट इट। हम्म। वही ठीक है। हम्म। 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 लाइन 3 to 5 इटरेशन का हिसाब। एक इटरेशन मतलब एक बैच पर एक अपडेट, एक पूरा डेटा और ट्रेन डेटा एक बार देख लिया। तो हमारे पास 77 ट्रेन इमेजेस हैं, बैच 16 5 बैच ड्यूरेशन epochs. Okay. Wow. 3 hours sleep is not optimal, brother.
What I know for sure, bro. I've been into that phase, and that's why I don't promote or advise anyone to follow such kind of.
Yeah, yeah, bro. Tomorrow I'll be recharged because I'm fixing my sleep schedule. I will sleep before 12 now every day, for sure. Because
That's the goal.
fucking I wake up and half the day is already gone.
That's the goal, bro. That's the goal.
What?
Nothing. Wake up early, early to bed, early to rise. Makes a man healthy, wealthy, and tiger likewise.
That is true. Mm. 77 images, है batch 16, 5 batches iterations, 5 iterations per epoch, 20 epochs, 100 total iterations. Hmm. Have you made paper planes in your life? वार्म अप का फॉर्मूला min 500 टोटल इटरेशंस 10 यानी टोटल का 10%, लेकिन 500 से ज़्यादा नहीं। यहाँ पर 100 डिवाइड बाय 10 वार्म अप इटरेशंस। डॉक्स वॉक थ्रू स्टेप 09.md में 3 वार्म अप इटरेशंस लिखा है। वो नंबर पुराना है, करंट फोन से नहीं मिलता। अपनी नोटबुक का प्रिंटेड आउटपुट ही सच मानो। यहाँ असली C100 रेशो बहुत कम है। असली डिटेक्शन ट्रेनिंग में 10,000 रेशो होती हैं। ये बात स्टेप 7 का लो MAP समझाने में काम आएगी। Let me run this block. इटरेशन 0 पर क्या होता है? अनट्रेंड हेड, बिल्कुल रैंडम प्रेडिक्शन, बहुत बड़ा लॉस, बहुत बड़े ग्रेडियंट्स। कोसाइन की भरोसा के तुम एक कटोरे बोल में ये डाल के और वो बिल्कुल नीचे सेंटर पर रखनी चाहिए, बड़े कदम से चलती है। Okay. Alright, bro, I think that is enough for today's
Hmm.
project work. We can do one lead code
Okay.
and
SGD. Stochastic gradient descent.
descent.
Optimizer.
Not decent, bro. Descent.
Decent. Decent. Optimizer. Okay, what is called? Let's do medium. Tomorrow's hard work. Tomorrow.
I'll go in the fucking order today.
Yeah,
Fuck you.
but that was fun, you know. It was yesterday. It was lead code was fun. Come on, let's do it. What is an lead code question? I think we
I'm
should.
looking 1 second. Where is lead code? Interview prep, lead code bank. Today we are doing flood
Number.
fill
What is the number?
733. It is easy.
Easy. Do you want to do
Yeah.
this easy one? Okay, yeah, let's do this. We'll see how quickly we can do this.
Wait 1 second. Oh. What does this mean? Like the logged question, that means that only premium users can have access to that question. Is that what it means?
Which question? Yeah, yeah. Like they could have some premium questions as well. But we can find those questions on like internet and every other place, and maybe on
I
forum
see.
to compile it.
Hmm.
So I don't usually worry about that a lot.
Hmm. Yeah, let's do flood fill 733 because I'm trying to cover all the questions that have already been asked. Oh, you already started.
Yeah, I was trying to take a look at the example. Like trying to understand.
Mistalo Valova. Mistalo Valova. Mr. Bombastic. Telephone Tastic.
This is going to be like super duper easy. So we should start the
A
clock.
timer. Bro, you already read the question.
If you want to do
Can't fucking control yourselves.
whatever, fucking crazy. Like what the hell is this?
Okay, 25 minutes. I'll start the counter. You are given an image represented by m cross n grid of integers. Image where image I and j represent the pixel value of the image. You are also given three integers SR, SC, and color. Your task is to perform a flood fill on the image. Starting from the pixel to form flood fill, begin with the starting pixel and change its color to color. Perform the same process for each pixel that is directly adjacent. Pixels that share a side with the original pixel, either horizontally or vertically, and share the same color as the starting pixel. Keep repeating this process by checking neighboring pixels of the updated pixel, then modifying their color if it matches the original color of the starting pixel. The process stops when there are no more adjacent pixels of the adjacent color to upgrade. Input image 111 0 101. 0 color 0. No color 2. Okay. NSRS is 1 1. Okay. So M would be len of sorry, image 0. Holy shit. M would be len of image 1. Cross n, and then SRSC is I create a queue. I want to form a append to the append S comma SC. Now okay. For I plus 1 J Q store and okay. I also have the directions. Also direction. Hmm. Oh, commas. Value. Center of the image of position SR, C is equal to 1, 1. So, what is SRS? Is it the coordinate or? Oh shit.
What happened, bro?
No, I understood like a flaw in my logic. So hygiene directions. Let's go. What the fuck were we setting?
Uh,
You hate to see it again?
Bruh, my fucking keyboard died. One second.
Charge it, bitch. You don't have a rechargeable one, or is it like the battery one?
Battery.
Uh,
Put no charge. Oh shit. Bro. Let me.
well, I think the time is up, I guess, or not.
Yeah, now it is up.
Okay, yeah. We
Yeah, you were able to do it.
only take that, but I think we did a couple of steps extra. Like we don't need that for loop unnecessarily.
Which one? This?
Yeah,
So did you already take a look at my code?
yeah. But yeah, that's what I'm saying. Like you are doing an extra step. Like you are necessarily increasing the complexity. That's what I'm saying. Like your approach is correct, but the problem with is why are you checking if RC comma if R comma C is not equal to SR comma SC? You need to check for.
Because I'm already putting like changing SR comma SC in image to color.
But the thing is, you need to check for the value instead of checking. It's never gonna be the same. That's what I'm saying. It's never gonna be the same. Like your RC comma SRC value, it's never gonna be the same.
Okay, wait. Let me first tell you my logic. What I'm trying to do. M N Q
Yeah,
direction
yeah, all
this,
that is correct.
and then for the for loop that I implemented, I'm trying to store all the values like index values into a queue,
Hmm. But
right?
but
And
but why?
this if
Yeah, yeah. Explain this. If why are you doing this?
this if is to basically check the like so that I can avoid this SR comma SC coordinate, so that I don't accidentally change it in my while loop.
Okay, so okay, yeah, go ahead. Go ahead. I will explain you the bug. Why would I think that?
And I think what you mean is I need to do it like this. Bro, wait. My fucking keyboard is not working. I don't know what the fuck.
Mhm.
Bro, what the fuck? Man. Okay, tell me what the bug is. I was gonna change this to this. Like,
Oh,
oh,
my question is like, why are you checking indexes? You're checking indexes.
oh right.
You are checking indexes, so that is incorrect. First of all, like even if you go with your approach that you are checking indexes, and that is going to be always false. And the other thing is like we we have to return the same array. We do not have to return a new array. That is the thing. We have to replace the values that already exist.
Uh-huh.
So I think if you even remove the for block, it's still gonna work. Like you are almost on the correct path, I would say. But you're just you're traversing your arrays twice, and that's what is not needed because we do not want to change the values of the ones that you have. Like if you look at the matrix on your left,
Uh-huh.
right? So if you take a look at the matrix, you have 1 1 1 1 1 1 0 0 1, right? And then on the right hand side, the values are changing 2 2 2 2 2 0 0 and 1. So as we can see, there is a single one that is left, right?
Mm-hmm.
But if we go with your approach on line 17 until 20, we are going to
Mm-hmm.
traverse each and every array, each and every index, and in
Yeah.
that index you will also append the last index that is going to be 3 comma 3
Mm-hmm.
you have over here, right? And
Oh yeah, that is true.
if you append that as well, then you and when you run your while loop, then
Mm-hmm.
it's going to change the value as well for that, and we do not want that. We can only change the values that are adjacent to sr comma sc. That is one of the constraints we have,
Mm-hmm.
right? So what we will do is we will start from SR comma SC. So you can remove 17. You can like comment out 17 to till 20. Yeah. And then in DQ you can introduce SR comma SC as your initial index. Yeah.
This one,
Yeah. Do a bracket. So you have to introduce a bracket.
like a tuple.
Yeah. Right. So once we introduce this, what's going to happen is our starting point will always be gonna be the value that is that they want as source. So SR comma SC defines the source and source from where you need to start your algorithm, right? Now
Okay.
now we have another situation. What if you take a look at the test cases, go to test
Mm-hmm.
and on click on case two. What if image is equal to color?
Mm-hmm.
Right? What happens in that scenario if both of them are equal? Right, that means we cannot change anything out, like it's already uh
Mm-hmm. It's an edge case.
yeah, so we have to write if image equal to color.
Image like some
If image
this.
like image srsc, if image srsc equal to color
Mm-hmm.
colon, then we return the image. right?
Mm-hmm.
And that's one of our case. Now what we will do is we will go into our while loop that we have. Go to while.
Mm-hmm. Bro, 1 second, bro. My fucking keyboard is not working. I don't know what the fuck happened. How the fuck should do I turn it back on? It's charging now.
It's charging. Wait for a while. It's gonna charge a bit, and then you can turn it on. That's how like I would do.
Now I'm not able to type like this because my laptop is on the stand.
Uh,
Okay, what?
Okay. So now if our image of nr comma nc
Mm-hmm.
is equal to our source, like all,
Okay.
yeah. So we have to change this equal to our image sr comma sc, because that is our initial value that we have from where we will start changing it. So sc,
Mm-hmm.
right? Then we will change the color of our neighboring nodes,
Mm-hmm.
and then we will append. We have to append on line 30. We will do q dot append,
Mm-hmm. And I comment see.
like in the bracket. You have to put it in the bracket. Yeah.
Mm.
And now we will return our image. Like go like you have to go far, go back, one more tab, one more tab, one more tab. You have
Oh.
to one more tab. Yeah. Now return the image, and go up. There is one more syntax error we have. That is in our queue. We have to put it into a bracket, into an array like this dq. Yeah, put this in an array. Like do sr, put sr comma sc in an array, not the dq. My bad.
Oh.
Put sr comma sc, like not outside the, yeah. Yeah, yeah. Do, now put another small bracket inside that array. Yeah, put another small bracket. Yeah, there we go. Yes. hmm DQ. Oh,
Oh.
yeah, you have, yeah. E. It's gonna be E.
Hmm.
We are failing somewhere. Let me take a look. Go to the code. For I comma j and r comma and c, we are popping left from our queue.
Take a look at this if.
Your M is correct. The row is gonna be also correct. Image is also correct. This is the image source. Oh, I guess image source is changing at some point. Okay, okay. I think. Oh, I know what's happening at some point. So, you know what? Create another variable called OG. We had to create a var copy so that we remember our initial. Create OG equal to image source SRSC. Yeah, and now change this image. Change the value on line 29 to OG instead of image source. Yeah, do it OG.
Like the whole thing.
Yeah, like the whole thing. Change it to OG.
Hmm.
Run it.
How is that gonna make any change? No, bro. That's the same thing.
No, I thought like while we are traversing, because I have the image and our comma NC is equal to color, and then we are appending and our comma NC. We are in the correct direction. Two is also correct. Image source. Go up. Go up. Image source is gonna be the color as well. Oh, okay. Oh, I guess I know where we are. Copy this. Copy the lines. Copy line 16. Yeah, copy line 16 and move it above line 14
Why is
because
that?
you so initial so we are changing the color, right? So yeah, go ahead. I think this should work.
No.
What the fuck? Why is it not running? I think run it in line. Review images source. We are returning the image as well. We have a queue. We have this length is equal to 1 comma and C, and it's gonna be our row and it's gonna be a column, and then we have checking for original character and that logic is perfect. Uh, Detection, we are getting the detection as well. Show me your test cases. Where are we failing? Let's look at it.
Oh, the first one. I mean, I think this is the second is an edge case. That's why it's
The
possible.
case 1, 1, 1, 1, 1, 0, source is 1, 1. And go down. What is our output that we're getting? We are getting 1, 1, 1, 1, 2, 0. That means our values are not getting updated somewhere.
Hmm.
So I think we should print what is the color value? Are you changing the color value at some point? No. The color value is gonna be the same. Okay, can you go down and let's start debugging it out. Let's scroll down a bit. Like go to line 25. Yeah, like go to line 27 and print image nr comma nc. After changing the value, we have to look for the value change, not the prior one. After we are changing the value or updating the value, yeah, let's look for that.
Print what? Image.
Image nr nc. Yeah. Yes. Okay. Okay, dude, we are not going into the queue. Okay, now I get it. So print Q on line 21. Print Q on line 21. Are we even going inside the queue? What?
No.
We are
I
not.
think there is something wrong with this, bro.
No, dude, that is correct. Okay, print m comma n. At least print m comma n. We need to get an std out. Got out.
Yeah,
Yes.
3,3.
Okay.
Yeah, there is no. We are not.
Okay, I think there is something happening on line 20. If you print Q on line 20, it should print. Print Q from line 22 to move it to line 19.
Okay, what?
Copy print Q from line 22 and move it to line 19. What I'm doing here.
Oh, bro, what the fuck is happening in my keyboard? What? What? What the fuck? 1 second. Bro, something has gone wrong with my keyboard. Bro. Yeah, where did you want me to
Line
or
19.
what
Line 19. Line 19. Yeah. Paste it over there. Yeah, like front queue.
front queue?
Yeah, let's see. Okay, go down. Okay,
Yeah, DQ.
so dude, I think there is some bug in your line 20. I think the way we have written it, it's causing some kind of.
Return image if image src color.
Oh, okay, okay, dude. I know why is it causing that error. You have to change it to OG. Change if OG equal to color. Yeah. Now run it.
Oh
There.
yeah,
There we go.
but why was that happening?
Because dude, we are changing the image source. We are changing the image source to color. The value of image source to color, and then we are checking it, and that's why
Mm,
it was throwing that. It was throwing. It was returning the image directly since the color matches over there.
I see. Hmm.
That's
Finally. Okay.
ran right. If you click submit, it's gonna run.
Yeah, I'm in the top 9.76%. Beats 97.83%. Oh. All right, I think that should be it for today.
Mm-hmm.
Another day streak maintained. We can do a longer stream tomorrow.
Yeah, yeah. All right.
Yeah.
Adios, guys. Video ended.